Good morning and welcome to SAT Prep. Today we're going to go over the worksheet, or the homework that was last night's problems numbers 1 through 7 on the data analysis and problem solving section for the SAT. Some of the questions you might have done fine on, some of the ones you might have had questions about, because again, people have had different experiences depending on the math classes you've been in, and it's possible that not everyone has seen all this information. So let's go over it, okay? The first problem gave you passports by state, so whether people have a passport, don't have a passport, or they didn't respond. And they broke it down per state in the graphic they gave you. The question was, which state has the highest proportion of passports owned? So for that, you would take in each state the people that said yes and divide it by the total people asked in that state. We're looking for the highest proportion. So for number 1, New York's proportion was 20,114 divided by 31,094. And that's 0.6469. Pennsylvania's proportion of people that had a passport, 15,987 over 29,986, and that was 0.5331, so it can't be Pennsylvania. They're lower than New York. Connecticut had 12,639 over 28,991, which is 0.436. Also cannot be Connecticut, so far New York is winning. Rhode Island is one of the smallest states in the nation. Only 8,004 people had passports, but we also only asked 11,735 people the question. And that's a proportion of 0.6821, which is actually the highest proportion of any of the states in our survey. So the answer is D, Rhode Island. Just because Rhode Island had the fewest people say yes doesn't mean that they have the lowest proportion. It all depends upon what the denominator is. Okay? Good. Number 1, done. Number 2 gave you information about, I think, a major chosen in a college and gender. And the question was, is there an association between the gender and the type of major chosen? So if you were to break it down and just see the numbers as proportions, it might make it easier to see. So we had degrees that were A and M and T, and we had the male and female breakdown. So if you just took a look of all the people who chose major A, whatever it stood for, that were male, you get 51% of people that chose major A were male and 49% were female. Of people that chose major M, 49% were male and 51% were female. And of people that chose major T, 53% were male and 47% were female. So the question is there any association between the gender and the major they choose? You would notice that if it was a high difference between male and female in a particular field. It actually has very little difference. They're all hovering around the 50% point. So there's no association. When there's no association, we say that it is independent, meaning the choice of major did not depend on a person's gender. So the best answer for that is answer B. There was no impact. So they are independent because they are all pretty much the same value. Answer B for question 2. Okay? If you want more help with that, let me know. We'll talk more about independence as we go. Okay, now on to number 3. So number 3 told you that there's a pattern, and we're starting with 20, and it's going to double every year. So it's going to go to 20, then 40, 80, 160, 320, for however many years we're in the cycle. And they gave you these graphs. Take a look at the graphs. Where does it need to begin? 20, right? Only A and C start at 20. The other ones begin at the origin, and that can't be the answer we're looking for because we know it starts at 20. It also tells you that it's increasing at a, let's say, an exponential rate. It's not increasing by the same amount every year. It's not 20, 40, 60, 80, 100, 120, 140. That will be linear. So this is showing you a picture that starts at 20, and as time goes on, it goes up and it goes faster and faster in a positive direction. That is the graph of answer C. You're just looking to see where does it begin. It begins at 20, and it's increasing at an exponential rate. It's not linear. That's the only answer that made sense. Number four, you have to understand the difference between different data gathering methods. An experiment is obviously something that you would test scientifically, whether one thing that we're testing has an impact on another thing. So for instance, if I want to know if blood pressure medication A is more effective than blood pressure medication B, I'm going to make an experiment where these guys get A and those guys get B, and I run the test and I see what the results are and I compare them. That's an experiment. I don't think that's what we're looking for in this particular problem, that we're looking to get people's opinion. Observational study, well, that's where it's almost like an experiment, except you're not really controlling anything. You're just watching to see what happens, and you're trying to draw conclusions as to whether there are connections between what you're witnessing and the desired result. An example could be a someone who goes out and he observes how animals interact in the wild. They're not trying to get involved, and they're not changing the animal's landscape. They're just watching to see what happens. And that's an observational study. Also, probably not the answer here. A survey clearly is when you ask people their opinions and they tell you, and that's the answer I'm looking for. Survey was option choice B. I don't need to write that down. Option choice B is the answer. Intuition is not a data gathering method. Intuition is basically another word for guesswork. Your intuition is what it feels like. That's never going to be a statistically significant survey method or data gathering method, I should say. So number 4, the answer is B. A survey is best. Number 5 was a little tricky. So there's a scale model that is 3 by 5, width by length. And then there's a real room that it is modeling. The real room is 44 feet long. We don't know how wide it is. And they want the area. Well, what we're going to do first is we're going to create a proportion to figure out what the width is. To find the area, we have to multiply length and width to find the area of a rectangle. So what you can do is say 3 over 5, which is the width over the length of the model, is going to be proportional, because scale models are always proportional to the width of the real room, which is x, and the length of the real room, which is 44. So you cross multiply 5x equals 3 times 44, which is 132. What we're going to have is a decimal answer, but that's okay. Divide by 5. And x equals, where am I? 26.4 feet. We're measuring these in feet, so that's 26.4 feet. Before we find the area by multiplying them, let's take a step back and look at the answer choices. What are they being measured in? We do have some square feet answers, but we also have square yard answers. Let's just be careful we don't make a mistake. If I multiply the two of them together, I will get the square footage, and it multiplies to be 1,161.6 feet squared. However, the answer choice with the number 1,161.6 is not in feet. It says yards. It's the wrong answer. Don't choose that. It's wrong. The units are wrong. But there's nothing that says 1,161.6 square feet. So let's see what the yard dimensions are. If I want to find out how many yards a length or a width is, and I have feet, divide by 3. There's 3 feet in a single yard. So if I divide this by 3 and this by 3, I'll find out how many yards we're talking about. And what I get here is, this one's 14.6, repeating, so call it 14.67 if you want, yards. And this dimension is 8.8 yards. Now, if I want to find the area in square yards, I'll multiply them together. So 8.8 times 14.67 is our answer in yards, which is 129.1 of roughly square yards. The answer choice that is correct is answer choice C. It's not exact. It's 129.06, but that's because we rounded right there, and that's why the answer is a little bit off, but the answer is still C. Again, don't be confused by labels. Don't be tricked by the SAT when they do something like this. All right, understand the units that you're measuring, and if the answer is not there in the right unit, you have to rethink your strategy. That was 5. Okay, number 6. Number 6 is something that I hope that you saw last year, but there's no guarantee. There was an statistics unit inserted into most geometry classes, and I think some, maybe Algebra 2 as well. And you were supposed to have learned about some statistics, including what this question is asking you about. And here's what you should have learned from last year, but if you didn't, we will definitely go over it again, probably tomorrow. This is called a normal distribution, all right? The curve that peaks in the center and tapers off to both sides. In a normal distribution, the mean is in the middle. Now, in this case, they gave you a mean of 50. In a normal distribution, there are 3 standard deviations on both sides until we get to like the little tail there. So 1, 2, 3 to the right, and 1, 2, 3 to the left. And it says here the standard deviation is units of 10. So that would be 60, 70, and 80. And that would be 40, 30, and 20. Now there's a rule that has to do with the normal curve called the empirical rule. What it tells you is that within 1 standard deviation on either side of the mean is 68% of all your data. Within 2 standard deviations to either side of the mean is 95% of all your data. And within 3 standard deviations to either side of your mean is 99.7% of your data. Why is this important? Well, the question asks what percent of our data lies between which 2 values? It was 30 and 70, right? I believe. I don't have it in front of me. I should probably look at it because I don't remember the exact question. So, hold that thought. Hold on. Because I don't want to give you the wrong answer. Okay. All right, so, yep, it was between 30 and 70. There we go. Want to make sure we get the right thing here. So, between 30 and 70 is between this value and that value. So they want to know what percent of our data is there. So here's what you would do. It's almost the, was it between 30, so 20, 30, I want to just make sure everything's set up right. Okay. Okay. So rather than, it didn't ask what percent is between 30 and 70. That was answer choice A says all of the data lies between 30 and 70. So is answer choice A correct? That's where I wanted to go with this. Losing track of what I want to say. Is answer choice A correct? Does all the data lie between 30 and 70? Well, you're looking at it and you can see there's extra blank white space. Clearly no. Oh, not all the data lies there. That can't be right. So answer choice A? No, we're going to say that's not a right answer. So let's keep looking. Okay. Answer choice B says 2/3 of the data, approximately, is less than 60. 2/3 is less than 60. Well, here's where 60 is. Now, is this 2/3 over here? Well, let's see. If I looked at all that, I know that to the left of 50 is half of everything, right? So there's 50% right there. So how much is this? Well, if there's 68% between one standard deviation below to one standard deviation above, then 34%, which is half of 68, is right there. So that's 50 and 34. That's 84%. That's a lot more than 2/3. 2/3 is 67%. So no, it's not 2/3. That's wrong also. So that can't be right. What's answer choice C say? It says 47.5% of the data lies between 50 and 70. Okay, well, 50 and 70 is right there, right? Well, 50 and 70, that's from the mean to 2 deviations out. Now that's half of our 95% chunk. What's half of 95%? It's 47.5%. Answer is C. Okay. I don't know how much you remember or were taught of the normal distribution, so we will almost certainly have a unit to talk about that concept. Number 7. Number 7 is just conversational. If I have a confidence interval, basically it's telling me where we believe data will fall. And again, there's probably another unit we have to talk about. If I want better data, more consistent data, I want a smaller margin of error. Margin of error is just what it sounds like. It's like wiggle room to be wrong. If I don't want to be wrong with as much room, I want a smaller margin of error so I'm more confident that I really have figured out what the population will do. It's always better to have more data to work with. So if I have more data to work with, it means I have a larger sample for my data. And that's the answer to the question. It's answer choice B. I want a larger sample in order to get more consistent, better data with a smaller margin of error, less room for error. Okay, that was it. So, as a special treat, there's no homework today. What we're going to do, though, is I want you to tell me, pardon me, I want you to tell me if you need more help, specifically with these types of questions. Hold on. Okay. You ever inhale dust? It's not good. So if you want more help with the empirical rule, number 6, or you need more help with proportions and scale models, number 5, or you need more help with the table from number 2, or anything, let me know. Send me an email. You could also make a comment on the Google Classroom stream that has this video, just telling me what kind of problems you want more help with, and I will target that as we go down this path. Other than that, have a great day. Thank you for watching.